Hi everybody, we are going to work on graphing systems of inequalities, and I'm going to use the DeltaMath.com website. I really like how we can do the graphs right on there, as well as the fact that I can do more examples in a shorter amount of time since I'm not drawing them out. So what's going to happen when we have a system of inequalities? It's just like a system of equations where we have two or more, this time inequalities, and what we're going to do is look for the solutions that they have in common. So if you think about graphing inequalities, that is when we need to decide if we have a solid line or a dotted line, and then whether we should be shading above or below. When we have a system of inequalities, what we're going to be doing is that solid line, dotted line, shading above or below, but we're going to be doing two inequalities on the same coordinate plane. And what we're going to look for is where they overlap. So first up, I need to graph this first line. So starting at +5, so I'm going to plant my first point right there. Slope is negative, so I know I need to go this direction. I'm going to go up 1 and left 6. I'm pretty sure I counted correctly there. All right, now I need to pause for a moment and decide how I need to draw the line and where to shade. So this is a greater than, so I need a dotted line. So I'm going to change the line, make it dotted, and then I want to shade it. So I'm going to click change shade. Now this one is greater than, which means I should be shading above. So I'm going to change the shading to above. So now I have a dotted line shaded above. All right, now I'm going to go to the second line. So I need to start at -5. So I'm going to put that first nail in right there. This one has a positive slope, so I need to be going to the right. I need to go up 3 and over 2. I think I counted correct. Whoops, hold on. Steady hand here. All right. I believe that's in the right spot. All right, so now I need to, again, look to determine what kind of line and where the shading should be. So on this line, I need a dotted line. This is less than, so I need a dotted line, and I'm going to shade below. So I need to change the line to dotted, and then I want to shade below. And remember that if you look at the y-axis, that's where you can determine if your shading is above or below. So when this point hits the y-axis right here, I want to shade below that point. So I'm less than that point. So this is perfect right here. Let's say you think you made a mistake. We can go back and alter line 1 if we need to. But now we're at the point where we have two inequalities on the same graph. So what happens is that up here in this blue-purple color, those are all of the solutions for this first equation. Over here in this green-gray color, those are all of the points that are solutions for the second line. So solutions for both lines are going to occur in the overlapping colored regions. Now, keep in mind that a solid line is a solution, a dotted line is not. So in this problem, the only points that are solutions are the ones that are in the double shaded. So points on either of these lines are not solutions. So now I'm asked to state the coordinates of a point in the solution set. So I need to pick a point that's in the solution set. I'm going to pick the point 9, 6. 9, 6. So if I look, the point 9, 6 is right here, which falls in the overlapping shaded region. So I'm going to submit my answer, and then bam, there we go. All right, let's try another one. All right, this one, first line, -2/3 x plus 3. So I'm going to put these on the coordinate plane and then state a solution. So I'm starting at 3. Slope is negative, so I need to go to the left. I need to rise 2 and run 3. So let's just double check that I did that correctly. I think that looks good. All right, so now we need to pause, and because this is a less than, I need a dotted line, and I need to shade below. So when I look at this, on the y-axis, when I look at that point, I've shaded the points less than -3. So I'm good on that one. All right, line 2, I'm starting at -8. So I'm going to nail that one right there. This slope is positive, and it's 3, which means up 3 over 1. So let's just double check that we graph that correctly. All right, this one should be a solid line. So the points on this line are solutions. And then it's greater than, so I want to shade above. Okay, now, again, if you're not sure about above or below, go to your y-intercept. So when I go to -8, I want to shade the points that are greater than -8. So these are the numbers that are greater than -8. So those should be shaded. All right, so now take a look at what we have for our graph. So in the blue-purple color, those are the shaded points that represent solutions for the first inequality. And if you notice, the line does not contain solutions. In this green color, these points are shaded because they represent solutions for the second inequality. And since the line is solid, points that are on the line are solutions for that inequality. But we're looking for a solution for the system. So what that means is it has to be true for both. So I need to look in this double shaded area, and I can choose a point that is on the solid line. I cannot choose a point on the dotted line. So for a solution, I'm going to pick this point right here. So what is that? 1, -5. So 1, -5. So I'm choosing a point that is on the solid line, which makes it a solution. I can choose anything in this shaded area out here. If I choose something up here, that would be a solution in that or for that inequality only. A point in this area down here would be a solution for that equation only. If I were to pick a point out here, it's going to be a solution for neither one because it's not shaded at all. All right, so submit, yes, and we got it right. All right, so again, just to reiterate what you're doing, you're graphing two linear inequalities on the same coordinate plane. You are doing the solid line, dotted line, and the shading. And then you need to determine a solution for the system, which means you have to provide an ordered pair that is true for both inequalities. And you can find that in the area that is shaded in both colors. Okay? And then keep in mind that points on a solid line are solutions, points on a dotted line are not solutions. All right, I hope that works. Remember, as always, if you need to replay or back it up to repeat something, please do, and then good luck with your assignment.